Okay, so we're going to start again, and this time we're going to pick up where we left off, and the first thing we're going to look at here is switches. Of course, I'm in the tour, and I showed you how to get there in the first part of this series. Um, yes, and you'll need an Apple computer to do this, of course. Uh, and you want to have Xcode and everything updated, including your computer, of course. So let's get started. Switches support any kind of data in a wide variety of comparison operations. They aren't limited to integers and tests for equality. Okay, not sure what that all means, but we'll just continue. Let vegetable equal red pepper. Well, we've already seen that. That's nothing new. We already know what that is. That's a declaration for a constant, and that's going to be a string. Vegetable is going to become the string red pepper. So then they make this. Then here's where they do the switch, and they're going to switch on the constant vegetable. So it's like depending on what that vegetable is, that'll be the case. So if the vegetable is celery, this is what they're going to do. They're going to print add some raisins and make ants on a log. If the case is cucumber, and oh, they do two at the same time. That's weird. Oh, cucumber, watercress, print. That would make a good tea sandwich. You know what's weird is they did different syntax, didn't they? They did different syntax than this one up here. So I don't really get that. Oh, no, they didn't. I apologize. I'm wrong about that. The only thing that's different is instead of one vegetable, they did two vegetables. So we'll have to play with this and see how that works. Now, down here, case let x, where x dot has suffix pepper. Isn't that interesting what they're doing there? So this would have, for a number of vegetables, if it ends, the suffix is the ending, I think, right? If it ends in pepper, they're going to print it's spicy, and then whatever the vegetable is. And the default is everything tastes good in soup. Haha. In case there's no, I suppose if there's no cases that match the vegetable that we're dealing with. So let's see what it says here for the experiment. Try removing the default case. What error do you get? Now again, I'm very lazy. I don't want to retype that. I'm just going to comment it out with 2 forward slashes. Boom. And I immediately see that I get an error. Let's see what the error says. Default label in a switch should have at least one executable statement. A default label in a switch should have one executable statement. Okay, so yeah, the default has to do something. You can't have nothing there. So let's put our do something back. So we'll take these forward slashes out, an uncomment, and then now we're printing, and now the computer's happy. Okay, so let's move on. Notice how let can be used in a pattern to assign the value that match that part of the pattern to the constant. Yeah, they're referring to this up here, to this constant, where x dot has suffix equals pepper. Is it a spicy red pepper? So I could have, you could change this, and it would. Let's see if I said, what's going to happen if I say lemon pepper, even though I'm not even sure if that's a vegetable. And then it changed it. Is it a spicy lemon pepper? So print, is it a spicy Oh, and then we use the string interpolation for x. That's pretty powerful. You see how that's working? Wow. And we didn't even, did we even really, we didn't even say that x was equal to vegetable or anything. That is amazing. So I'm starting to really see the power of this here Swift. So enough about my my being awestruck. Let's move on. So after executing the code inside the switch case that matches, the program exits from the switch statement. Execution doesn't continue to the next case, so there's no need to explicitly break out of the switch at the end of each case's code. Man, that is clean. If you've looked at some of the old, traditional applications, yeah, there's break statements in there and stuff, and it cluttered. Compared to this, those look cluttered. This is sweet. So you use for-in to iterate over items in a dictionary by providing a pair of names to use for each key value pair. Dictionaries are an unordered collection, so their keys and values are iterated over in an arbitrary order. Whatever that means. So now we're into something else. We're talking about we're back to talking about a dictionary, and then we're going to loop through it or iterate. So loops are cool, iteration is cool, so let's check it out. They say it's an unordered collection. All right, let interesting numbers, that's our dictionary. Our keys are prime, Fibonacci, and square, and those are the values to the right of those. And then we're going to come down here and then we're going to loop through them. So first of all, we declare a variable, largest, and we set it to 0. And then we say, for our loop, we say for kind numbers. So kind is over here. Prime, Fibonacci, and square, those are the kinds. And then the numbers are to the right of those in interesting numbers, which is the entire dictionary. Okay, so first we're going to loop through. See, there's two loops here. There's an outer and an inner loop. So this is don't stress if you don't get it right away. If you're new to this looping and stuff, but once you get it, you'll say, "Wow, this is." Perhaps you'll appreciate it like I do. How clever this is. Okay, so now what's going to happen in this loop? We loop through the kinds one at a time. That's our outer loop. And before we move on to the next kind, we have to, for each kind, we're going to loop through the numbers for that kind. That's what's happening. Okay, so for number in numbers, okay, if number is greater than the largest, and on the first one, the largest is 0, so pretty much any of these is going to be greater than on the first go. And what's going to happen on the first go, by the way? It's going to start with prime. That's going to be our outer loop. And then we're going to loop through the numbers that are associated with the prime. Okay, one at a time. And then we're going to make that comparison. If the number is greater than the largest, and if number is greater than largest, then we're going to update largest, and largest will become that number that was greater than the largest. Ain't that cool? So that's another thing we're doing. We're sorting out. We're going to find out which the largest number is for this entire dictionary. And of course, because it's a computer, it's going to do it in record time. And that's what's happening. And it even showed us what the largest number is finally, once it pops out of the loop. Now take a look at these brackets, they're important. And they have to be closed, and there's indenting. The indenting actually helps you. It's not like Python where the indenting is actually part of the syntax, if you know what I'm talking about with Python. This is just These are still required, but it'd probably be okay if we didn't have them all cleanly indented. The indenting actually helps us to see what, to be able to read the code, to look at it. Okay, so this closing bracket here matches with the initial statement up here with the for. See how that worked? And then this one matches with this one. And this one matches with the if. And the indenting is what helped me to see that. So the experiment is add another variable to keep track of which kind of number was the largest, as well as what the largest number was. All right. Well, which kind of number? So I could say, I could create something called largest kind. All right. How about, so sometimes you just have to try stuff. Largest kind equals kind. Will that work? For number in numbers. Now, oh, so we'd have to do something similar here, wouldn't we? Var oh. Huh. See what I'm doing here? And I'm going to say largest kind. Sorry, I stopped talking there. You probably thought I... Okay, so... Oh, that totally worked. Did you see how I did that? So I basically followed their example, and I realized that I had to do the same thing they did, and I had to declare a new variable called largest kind is what I named it. You could name it anything you want. And of course, I had to initialize it, and I initialized it to an empty string. Okay. And that seemed to work, as far as I'm concerned, huh? And then in our loop, it's keeping track of the kind, right? But I followed their example, just like they had assigned the number in numbers to the largest after they did the comparison to see which number was the largest. You see, because once it's found the largest in this dictionary, in the entire dictionary, it's going to pop out of the loop. Why? Why would it pop out of the loop? Well, because it would be done iterating, I suppose. You see, because it's, no matter what, even if you had the largest number right at the beginning, which we could do to demonstrate, it still has to iterate through the entire dictionary. Why? Because it doesn't know, the computer's dumb. It doesn't know that first number is the largest, not until it goes through and checks every number in the dictionary. And then once it's gone through the entire dictionary, whatever, based on how this is coded, whatever's in largest, that's the largest number. And once we've iterated through the entire dictionary, we're going to pop out of that loop, and then we'll be down here to print. So I did the same thing they did. I just followed their example, print largest, and then print my new variable that I created, print largest kind, because when it finds the largest number down here in the loop, well, that largest number is going to be in the, let's see, it's going to be in the largest kind. You see? That's right. Largest kind in this case was square. Why? Because 25 was in that square. If we put 200 down here in prime, add a couple zeros to that, it'll loop it through the entire dictionary, and it'll realize that 200 is the largest, and it's going to know that it found, since that'll be the last one, it will also know oh, this is cool. See, what it's doing the same thing with largest kind. Each time it's updating it. So for example, initially largest kind will be just an empty string. And then of course we start our loop by going to the first kind, which is prime. And and we're going to loop through 1, 2, 3, 4, 5, 6 numbers in prime, right, before it pops to the next kind. And for each one of those in that first situation is the largest kind will be prime, because that's the only one so far. It hasn't looped to the other two. This is really, this is slick. This is like how people come up with this. This is really genius. I appreciate how clever this is. I hope you do at some point, if not always already. Okay, so let's move on. We won't get too enamored of that. We'll just keep going. So next, use while to repeat a block of code until condition changes. A condition of the loop can be at the end instead, ensuring that the loop is run at least once. So the way I understand it, this is just another loop, and instead of using the for syntax like we did above, it's going to use the while. Okay, and what they're saying is, to give us a little clue, is we do this, and we make the condition of the loop at the end, ensuring that the loop is run at least once. Excuse me. So, okay, we set a variable in, and we assign it to, initialize it to 2. I want to use the proper syntax or grammar terminology in my speech as well as the code. So while n is less than 100, n is n times 2. So each time it loops, as long as n is still less than 100, it's gonna update n. It's gonna double it at each time. It's kind of cool. And then what we're doing here, we're going to print n. All right. So it looks like it's going to do it 6 times. I'm just curious to see how that looks. So I come over here to the right. I'll do a quick look, and it gives us a graph. And what I finally realized is that what's happening. The reason why we're getting a graph is because we're in a loop. That's what I've seen so far. I don't know if that's completely accurate. We'll just keep on keeping our eye on that. Sometimes we might want to have, instead of a loop, we might want to print the actual value. So I'm just curious, can we do that? How would I do that? Well, I would say, how about if I say print in? Would that work? Pint in. Whoops, that's a Freudian slip right there. It's not time for a pint just yet. Print in. Okay, so there we go. Now we say print in. That's not really what I wanted. You see, because I have my print statement, inside the loop, so why isn't it doing it? I don't know. How about if I put it above? Will that work? Not sure. To me, that should have worked what I had. Okay, and so I'm not sure why that's working. Why it's not working, I mean. What if I just put in? Huh. Yeah, I don't know. Okay, so we won't get hung up on that. So on the first while, they have the while at the top, and the condition is at the top. And then it looks like they're doing a second one, and this is m equals 2. And instead they have the repeat. They're doing a repeat while. So again, they're doing the same thing as above. They're doubling m each time with this statement here, m equals m times 2, for each item that they're looping over, which we haven't even done that yet. We don't even have like an array or anything to loop over. We really just have the one value in each of these cases. Does that sound right? Well, yes, but the way this is structured, that's all we need, because each time we're going to get a different number. Why? Because within the loop, we're doubling. Each time we're doubling, we're updating and doubling the variable that we start on. So that's what gives us those values. What's different about this second loop, however, is the while is at the bottom, the condition is at the bottom. So yeah, it'll do it at least once. But basically, everything is the same, unless, of course, like here, if we made n 200, it's not going to loop as far as I know, because yeah, it's not looping. How can it loop? Because I made it 200, and 200 is not less than 100, so it's not even going to do the n times 2. It's not even going to do it one time. However, if we come down here and do it, in theory, it should run it at least the one time, and sure enough, it does. And it updates m and doubles m, and that's shown over at the right where it shows the 400. Okay, so that's a big difference. That's a very big difference. And it depends, which one you use depends on what you want, what you're trying to do, what the situation calls for. Okay, so let's move on. You can keep an index in a loop either by using ... less than to make a range of indexes, or by writing an explicit initialization, condition, and increment. These two loops do the same thing. This is our example. Our first loop is 0 for I in 0 ... less than 4. First for loop, and then we increment it by the I value. So that's from 0, 1, 2, 3. See, it's not going to do 4 because that would be 5 items. And arrays, for example, typically start with 0, as far as I know, or especially as far as the index. And then we print the first loop. Print the first loop. And so first loop, yeah. So first loop starts out at 0. Then it goes 1. Then the next one is 2. And you could do it on your own, because I'm lazy, and that the first loop is basically accumulating or adding, and that's going to add up to 6 in the first loop. For second loop, same concept. They're initializing a variable, setting it to 0, and they're going to use the syntax that many of us might be familiar with. That's more a traditional syntax where you on this one line for the initialize a variable I, which is going to be our index more or less, and we set that to 0. We do a test with a condition saying I is less than 4, and then we increment I, and as long as we're less than 4, each time we're going to second for loop, and we'll increment I. And that's what they're saying, is basically these loops are synonymous with each other. Yep. So let's see if we can get to the next one. Next one. Okay, so that's what we did. And I'm going to take a little break, and we'll come back and start again with functions and closures. Okay? Thank you.